Right, let's kick off. The first thing I want to say is thank you very much for joining us on this Monday morning, bright and early, and that's how we sometimes like to do our CTI sessions. So I'm Josh Darby McLellan. I work here at Feedly and have been here for the past 3 years, primarily working on the client team. And my background is as a CTI analyst working in the finance space and the tech space, originally from the UK, but worked mostly in North America, in particular in Canada. And today, I'll begin by doing some housekeeping, and then we'll dive into our CTI session topic, which is from malicious packages to actionable intelligence with open source malware. And I'm very excited to say we're joined by Paul McCarty, who I'll be introducing in full later on. So, first few things to kick off around housekeeping. We are recording this session, and everyone will be sent the recording afterwards. And we do enable Q&A, and this can be done throughout the whole webinar. There is a Q&A box, so please use that. Participants won't be able to access the chat, but you can put all your questions into the Q&A, and we'll make some time for Q&A at the end of the session, but I'll also interrupt Paul rudely at different times to pop some of your questions. So feel free to ask them at any point. I've got 4 slides to run through, and then I'll pass over to Paul, who will jump into the main presentation itself. And the first thing that I'm going to do is provide you with some context on Feedly. So for those of you who are new to Feedly, it's a platform that essentially acts as a huge filter, and it takes in tons of trusted sources from the CTI space. That they all get processed by our AI machine, and we do all sorts of extraction, tagging, and the identification of very useful tactical threat intelligence contained inside of that content. At that point, we then have all of that content mapped in our threat graph, and in particular, we're mapping the relationships between things like threat actors, CVEs, malware families, TTPs, IOCs, so on and so forth. And then through using Feedly, you can access all of that information from the threat graph. Like you can set different filters using AI feeds that you can personally customize. So you can say, hey, I'm just interested in finding out what CVEs are affecting the Mac OS. And I'm interested in TTPs impacting the finance sector. And you can start to filter and extract insights from that threat graph specific to your environment and your PIRs. Beyond that, we've also built in some additional new features. We are adding Intel agents into Feedly and have some big announcements coming this week about that. And we also have different research tools, so you can ask questions of the threat graph in natural language. You can build reports from this content that you can find inside of Feedly. We also have an automated newsletter feature and all sorts of integrations, including an MCP server. So there's all sorts of ways that you can query that threat graph and access this data taken from open source, do it in a nice, neat, structured fashion, and action that intelligence a lot more quickly than using the manual route. So that's Feedly, and you now have some context on Feedly. If you have any questions about it, feel free to reach out. We do have a free trial. And now onto the webinar itself. So here's the structure that we're going to follow. As mentioned, I'll introduce Paul and then pass over to him, and he'll begin by providing some context on how malicious packages operate, then how we can collect threat intelligence from the package ecosystem, and then finally, we will get a demo of open source malware. Now, open source malware is a brand new platform that Paul has worked on. He's the founder, he's the main maintainer, and this is an open source project that he's released to the community, and it's all about helping you collect threat intelligence from malicious packages, and it's brilliant. So that's why I'm super excited to have Paul with us today. So who is this Paul? This guest speaker that you have here in front of you. As a quick introduction, Paul has founded multiple startups that started way back in the 90s, and he's worked for all sorts of household names from NASA to Boeing to the US military and even the Australian government. So an international man of mystery. As mentioned, he's the founder and maintainer of open source malware, and he'll dive into that and talk a bit more about it. But he also has a day job because who doesn't love to be busy? And he's the head researcher at Safety CLI, as well as a DevSecOps OG. So, Paul, thank you very much for joining us. There is a game here that we like to play on CTI sessions that Sean started, and I'm continuing the tradition of. And it's a finish the sentence game to get you warmed up. So I'm going to start a sentence and then you're going to finish it and just say the first thing that springs to mind, the organic reaction. And there's going to be three of these. So the first one is the skill I wished I developed earlier on my career is
Ooh, public speaking.
nice, good choice. It's hard to automate away public speaking. That's why I've always liked to do it. The next one is the future of the CTI industry is.
Integration of software supply chain data.
Ooh, okay, I like that. I like that. So everyone take note. We've got a future skill, we've got a future development in the CTI industry. And the third one is the coolest thing I've done this year outside of work is.
Oh, I'm in Park City snowboarding with my family right now, so that's probably the coolest thing this year.
Excellent. So you're a snowboarder, not a skier?
I'm definitely a snowboarder, definitely not a skier.
Very nice. Well, thank you so much for making time for this webinar. Really appreciate the fact that you're doing this whilst on vacation. And I hope that we won't keep you too long from the powder. With that, I'm going to stop the screen share and pass over to you and let you run with it.
Sounds good. Here we go.
Nice. And just as Paul's doing that, as a reminder, if you have any questions, chuck them into the Q&A. And Paul, I will pepper some questions your way throughout the presentation. But with that, I will shut up and let you run.
Hey, cool. And by the way, I love that format, that kind of interactive format. I always encourage that when I do my talks. But thank you, hey, for having me here. I am in Park City, so I'm in the U.S. right now, but I am based in Australia. I've been there full time for 10 years, and I just want to give a shout out to Feedly for putting together this opportunity. I really love it. My name is in fact Paul McCarty. I am the founder of Open Source Malware, but Open Source Malware is an open source project and it doesn't make any money, and so I have to have a full time job, and I want to give a shout out to Safety, which is a British Columbia. They're based in Vancouver, an ASPM company, building a great reachability product, and I love working for those guys as their head of research. What we're going to talk about today is kind of open source malware, but to get there, we have to kind of talk about open source. And as a purveyor and user of open source, I realized a long time ago that I need to be part of the process. I need to be part of the solution, right? And so I write a lot of open source tools. I create and maintain and write a lot of open source tools myself. Probably the one I was most well known for is the DevSecOps playbook, which I wrote 3 or 4 years ago. But I've been writing a bunch of tools around malicious package detection and kind of the machinations of how you have to do that. And so I highly recommend that you check out my both my GitHub and my NPM accounts. My handle is 6 Mile because I'm from 6 Mile in Detroit, and you wouldn't know it, but anyhow, that's my handle, 6 Mile. So check me out at github.com/6mile. The same thing on NPM. Um, what we're here to talk about today is malicious packages to actionable intelligence with open source malware. Now, the cool thing is I actually went to my first conference this year in Berlin, and I talked about this. I gave a almost an hour long presentation on how to get CTI data out of open source malware kind of components, and you can follow that link there, and you can check out the YouTube video. The whole thing is online, and I really enjoy it. I hope I get a chance to go back to one of the first conferences in Europe next year.
Hmm.
Let's start by talking about the different types of risk, right? There's two types of software risk. The first type is the accidentally vulnerable risk. And this is basically when a software engineer or a team of engineers accidentally add vulnerabilities to software. And this is what the whole OWASP top 10 and this whole industry is built around, this idea that there are flaws in source code, things like not sanitizing input, not encoding output, all those kind of classic things, including using out of date libraries because they have those vulnerabilities in them. OWASP top 10 is all about this. Now, the issue here is that these tools that address this first type of software risk, they produce findings like, hey, in this library, you've got this vulnerability in prototype pollution or regex denial of service or whatever the case may be. And how a team reacts to that is complicated because it's not a Boolean thing. It's a finding. It's like you should replace this or get rid of this. And that's why the whole kind of application security posture management and application security tooling space right now is focused on reachability. This idea that like 5% of vulnerabilities are actually exploitable in source code. But the point I'm trying to make here is that accidental vulnerabilities are not creating the findings that InfoSec teams and CTI teams are built to natively consume. And that's why I want to talk about the second type of risk, which is the intentionally malicious risks. Now, these are threats produced by criminals. Sometimes a small percentage of those, a very small percentage of those, are created by security researchers and bug bounty researchers. But the vast majority of it is created by bad guys. Now, some of the techniques they use are things like obfuscating the payloads, using not native JavaScript payloads, for example, which run in the browser. But these packages, these malicious packages, and these malicious open source components still have the kind of typical thing that we see in kind of classic malware. They have C2, they exfil data, the kind of classic signs, right? And the cool thing is, this type of software risk does produce findings that CTI teams, threat researchers can consume, right? So things like IP addresses, domains, file hashes, email addresses, GitHub accounts, things like that. These are things that we can pull into our existing tools and do something about. So we have this huge ecosystem that's building all these application security tools. And the problem is those don't really address the malicious packages or the open source malware because they're focusing on those accidental vulnerabilities. So these are the things that I wanted to kind of address in my work. Those tools, those application security tools don't produce those. So I wanted to be able to address those myself. Now, real quick, I just want to be brutally honest here. Application security teams typically think that they've got coverage for open source malware and kind of malicious software components with their application security tools. And as I've just mentioned, and this is not picking on any particular tool, but as I just mentioned, most of these application security tools cannot help with malicious packages and malicious open source components. Now, similarly, InfoSec teams and the size of those out there, they think they've got coverage in the form of existing security tools like EDR, right, and NDS and whatnot. So like the NIDS, this idea that both of these teams think they have coverage for this other type of software risk is not true. There's this huge gap that you can just drive right down, and bad guys are doing that every day. Some of the types of issues that we see in in these ecosystems, and we're talking about NPM, PyPI, Ruby Gems, Docker Hub, NuGet, and others, things like dependency confusion attacks. And I'm not going to go into a lot of detail today about dependency confusion or some of these other kind of types of attacks, but these are the high level kinds of attacks that we see bad guys perpetuating on these ecosystems. Account takeover. This has been a huge one over the last 6 months as very, very popular NPM maintainers. So these are developers that build these super popular NPM packages that get like 2 billion downloads a week, right? Everybody is using these packages. Bad guys are targeting those maintainers. Typo squatting. I think a lot of teams think that typo squatting is not a real risk. And the reality is, I'm here to tell you, typo squatting is probably the most common way that I see teams get popped. And the reason why is that there's just so many different types of typo squatting. And with a lot of, kind of uh, more recent crypto and blockchain libraries and whatnot, the naming constructs are confusing. So typo squatting is a very, very common technique that bad guys can be successful with. A big one we've been talking about lately is browser extensions. And this is bad guys are definitely targeting browser extensions, especially AI and kind of dev tools, developer tool type browser extensions to be able to compromise the software supply chain. And unfortunately, all of these types of attacks have become automated. And in my day job, I actually watch these attacks happening in real time. And I just wanted to kind of give everybody in the webinar a kind of an idea of where these attacks are happening. So this is data coming out of opensourcemalware.com. We'll talk about this a little bit later, but I think it's really important to take a look at this and to see that the vast majority of threats exist in one ecosystem, which is NPM. Now, PyPI, the main Python ecosystem, is number two and has roughly about 10% of the total volume that NPM does. But the reality is NPM is where most of this bad stuff is happening.
Yeah.
And so because of that, Go ahead, Nick.
Sorry, that's super interesting because when I watched your first CTI talk, you had some data and graphs about that, and now we're seeing that exact same like pattern of NPM being targeted inside of your own data. So that is a super interesting finding, and it's actually linked to a question that we had in the chat, which is the main
Sure.
source behind me interrupting you.
No
Um,
worries.
so this comes from Mike. Mike asked if malicious packages can operate undetected within open source ecosystems. What assumptions do we make about trust in these ecosystems, and how might these assumptions influence the way we collect and validate threat intelligence?
Oh my gosh, that is such a there's so much to unpack there. I mean,
Yes,
I
it's a
think
great
the
question.
the the reality is that part of the problem is that our software engineers are given a lot of trust themselves, right? And
Mhm.
so then the corporation or the enterprise they work for where's the risk or the liability that we've given to those software engineers? And this is not to pick on software engineers, but we've incentivized them to move quickly, right? We've not incentivized them to do that securely. And so, because of that, we don't encourage them to use some of the tools that they could be using to gain some of that visibility that CTI teams could use. So, for example, let me posit a question. How many
Mhm.
of us actually know exactly what libraries and versions of those libraries all of our software engineers are deploying on their local machine as they're working on development instances, right? The reality is, most of the time when I ask enterprises this question, they have zero visibility or at best, very little
Mm.
visibility. So I think back to the root of the question, I mean, I think the reality is that we don't want to not trust our developers, but the reality is that's where many of these attacks we're going to talk about today, especially these JavaScript attacks, which, as you'll see, based on that slide a second ago, Josh, and another slide that you've seen before in my CTI talk, um, those JavaScript attacks are the particularly pernicious ones, right? In the sense that there's multiple things they can do. Let me actually show that to you here.
Yeah.
So here's the slide you were talking about. According to a Sonatype study from 2024, they found that 98.5% of all malicious package attacks are sourced and hosted in one ecosystem, NPM. PyPI is less than 1%. So the vast majority of the malicious packages are in NPM. And you couple that with the fact that JavaScript itself is just a much more promiscuous language. Now, what do you mean by that, Paul? What I mean by that is that every language is going to have direct dependencies. Like I'm going to call Express if I need to build a web server, right? Or I'm going to call Lodash if I need to parse regex or whatever the case may be, right? But those libraries that we're calling then call another set of libraries, and we call these third-party or transitive indirect dependencies. And JavaScript, this is based on data from GitHub itself. JavaScript, on the average, has 10 top-level dependencies, but 683 indirect transitive dependencies. Number two is PHP with 70 indirect. So you just see there you have all the maliciousness happening in npm, and your JavaScript packages, projects just call a lot more packages. Those two things come together and combine into this just terrible, terrible kind of situation, which is where we are now. Really quickly, I want to spin through these, but some of the things that make JavaScript malware a little bit different is that JavaScript malware doesn't detonate like typical malware. Um, typically you will either need to install a package for the install scripts to detonate it, or what most of the good high quality threat actors do is they actually build their packages to be used on import. So when you call a function, that's when the bad thing happens. And those are very, very difficult things to detect. We'll talk about that a little bit more in a second. Unfortunately, skills from kind of traditional binary malware analysis don't necessarily cross over. So people that in an organization that are really good at doing kind of classic, malware decomposition and analysis aren't necessarily going to be great at open source malware because they're two different things. And the software package as an atomic excuse me, means that the vulnerability and the malicious data is actually stored together in this atomic deployable, publishable thing. And so it's not just that the package itself has this bad payload, it's that it comes with this beautiful package.json that will deploy it for the bad guy. And that's built into NPM, right? And it's just crazy. And frankly, the fact that just there's not a lot of teams that realize this is a true threat, and there's not a lot of visibility, which we were talking about a second ago. And finally, NPM. NPM itself has dramatic systemic flaws. It was built in a time before security, 2011, 2012, by a small group of software engineers. JavaScript itself comes with no batteries included. And what that means is there's this expectation that anything you need to do in JavaScript, you need to call a library, right? Which is why we have libraries like is odd or is even or is number. These are libraries that are just a few lines of code that basically say, is this string that you just gave me a number, right? It's just kind of these silly, kind of ridiculous things are expected to be libraries that pull it in. And that's why we have an average of 683. Oh, and I forgot to mention that number was from 4 years ago. The number now is actually over 1,100. So the average JavaScript project on GitHub now has over 1,100 transitive dependencies. The barrier to entry is really, really low in NPM. Anybody can create an account and start publishing packages in like a couple of minutes. Uh, Unfortunately, NPM still has install scripts, these lifestyle scripts, which bad guys use for remote code execution by design, which I think is a great quote. And it's exactly what it is. It's like, here is the perfect way to deploy your malicious package. It's built into NPM, no worries. Anybody can claim a namespace on NPM, which to me is still crazy. So for example, if at Microsoft in NPM, which is a scoped kind of namespace, if that's available, Josh can get it, Paul can get it, anybody else can get it. You don't have to prove you're from Microsoft, right? Now, obviously, at Microsoft is not actually available. It's been taken years ago. But the point is, any of these new companies kind of coming up now, if a bad guy says, "Oh, I'm going to go and grab the namespace," they can and they can own it. They don't have to prove that they have a domain name. They don't have to use a text file in DNS. They don't have to show that their email address comes from that domain. They can just get it. Um, Package metadata can be faked in NPM, which I think a lot of people don't realize. For example, the contributors, that's just a field that you can drop in there. The GitHub repo is just a field you can drop into the package.json file. So this metadata that people are trusting to validate the legitimacy of the author and the package itself are in fact just things that the bad guy put in there. Um, Account takeover is very, very easy, typically doesn't require MFA. Now, NPM is addressing some of this now because of these huge issues, account takeover attacks they've had in the last couple of months. So they now are getting rid of some of these short-lived NPM RC tokens. GitHub is doing something similar. But the reality is that account takeover in NPM is particularly easy. And GitHub and unfortunately NPM take a long time traditionally to remove malicious packages. So as an example, I have personally disclosed, I don't know, hundreds of packages, maybe even thousands of packages to NPM and GitHub. And one time, one of those packages, express.xp, it took them 5.5 months to remove a package. So I told them in December of 2024, and they didn't take it down until May of 2025. That means 5.5 months. A package they've already been told is malicious and deploying a malicious payload is still out there and being able to be downloaded. Something else, download statistics in NPM can be faked. It's super easy. I wrote a tool that allows people to do that. Other people have done the same thing. All you need to do is call the API endpoint, get a 200. You don't even have to wait around to get the payload. You can just do that and you can boom, 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 and you can create millions of downloads or the appearance of millions of downloads very, very quickly. And lastly, and this is super important because we're going to talk about this, GitHub Security Advisory and NPM, they do not track malware data. They don't track the authors or contributors or any of those metadata points, which are important here. Um, as I said, these are some of the reasons the NPM is the most malicious registry in the world. The barrier to entry is very, very low, and JavaScript itself can run either in the back end or in the front end. And I think that thing is really, really unique. JavaScript payloads can be used in different ways. And I think a lot of teams really kind of haven't come to the realization. So, as an example of that, a lot of the North Korean stuff is actually targeting developers. What they basically want the developer to do is to run that in a dev environment on their laptop. Then they get access to their browser. Then they can steal their sessions, their tokens, all the other things that you can get access to when you get access to the browser. And then there's other JavaScript packages, which are kind of using Node in the backend scripting functionality to do kind of more traditional things like, you know, pull things from a server and whatnot, right? And download things and create reverse shells. So JavaScript itself is very, very flexible and can be used in different ways and in different types of payloads. Really quickly here, this is from a company called SafeDep. They basically took a look at all of the malicious packages that they had seen in a year and kind of broke those down by the types of attacks they saw in payloads they saw in those different malicious packages. This more or less matches up with my own experience. I think the reality is that now we're seeing the quality, unfortunately, and the maturity of the malicious actors deploying open source malware is just getting a lot better, which is bad for us, by the way, just to be clear. So I think there's a lot more of the kind of sneaky stuff happening, and we're not going to see as many of these obvious attacks like the install hooks. It's just really easy to look at a package.json and see that it's calling something in the install script. Bad guys are learning that, and they're being able to create more mature malicious payloads. So how do some of these open source malware components evade existing security tools? Well, first, open source malware, typically they're interpreted languages. It's JavaScript, it's Python, right? It's not a binary, so there's no hash, right? A lot of these kind of tools and processes that teams have for kind of keeping track of badness aren't, aren't functioning in this open source malware world. Um, so a lot of the payloads that we see are highly iterative. They'll deploy two different payloads a day, right? And so the tracking that is very, very difficult. And I've got an example of that a little bit later here. Unfortunately, a lot of the sandboxes that people are used to using for kind of classic malware analysis just don't work with JavaScript or Python payloads. Obfuscation. Oh my gosh. Obfuscation is such a pain in my butt because JavaScript itself is an interpreted language. It runs in your browser. You can just look in dev tools and you can see what's happening. So bad guys have to come up with a way to keep you and I as researchers or threat analysts from understanding what their JavaScript is doing. And so they use obfuscation. Now, the problem is that many InfoSec teams think that obfuscation equals bad thing, and it's not. Lots and lots of teams use obfuscated JavaScript for totally legitimate purposes. The most common is, there's some sort of business functionality or something there inside of the JavaScript. They just want to kind of hide from their users, and so they obfuscate it, and that's totally legitimate. Um, and then unfortunately, you can kind of stack different obfuscation methodologies or mechanisms on top of each other in a unique way to make it very, very confusing for the researcher to figure out what that payload is doing. And that means that humans have to get involved. And the more that humans have to get involved, just de-obfuscating the payload,
Hmm.
is time wasted, unfortunately.
And on that topic, is there any LLM assisted de-obfuscation tools that work? And this is a question from John in the audience.
Yes and no. There's a tool called WebCrack. So if you search for WebCrack, you can download it as a library and run it locally if you want to, although it sometimes can be picky. Or you can just use the web version of it, which is a pain in the butt because it's harder to obfuscate, obviously. But
Mhm.
sorry, harder to automate, not obfuscate, automate. Um, but besides WebCrack, I think the LLMs are pretty good at de-obfuscating code, and I use that every day myself. The
Mhm.
problem is as we all know, LLMs get stuff wrong, right? And so a really good example of that is like last week, I was doing a piece of research, and the IP address and the port that the LLM was telling me just wasn't matching up with what I was seeing. And the reality is, it just hallucinated the port. It basically was said, five, whatever it was the port that the C2 was using, and in fact, it
Mhm.
wasn't. It was North Korean, so it was using port 1224. So you got to be careful about trusting what the LLM tells you too much. But yeah, to your point, I use LLMs almost every day to deobfuscate
Yeah.
malware.
And based on your testing, which LLM would you recommend?
I use two.
Okay.
I use the new version of Gemini, the new model in Gemini, and I
Mhm.
use Claude, the latest version, Opus 4.5. I've been using Claude and Gemini before. Um, Gemini is, without going into too much uh, depth, uh, Gemini has had kind of up and down success with the obfuscation. The latest model is very good at it, so I would recommend both Gemini and Claude, the Anthropic model. Um, but getting back to open source malware here, as we mentioned earlier, because it runs in a browser and it does its damage a lot of time in the browser is the new attack surface. And I think that's a lot of teams just kind of haven't come to terms with the fact that a developer's laptop, which might or might not be running EDR, is being targeted. The browser on that laptop is being targeted to affect both, payload detonation on that laptop, but then also, attacking the enterprise too as well. And those attacks, as we talked about a minute ago, can be very, very flexible. You can
Yeah.
see all kinds of things from the browser, and it's been particularly effective for crypto theft. The North Koreans continue to target individual developers as well as developers that work for crypto organizations or for organizations in the payment space or what have you, because they know they can get some money out of just the developer themselves if they have crypto, if they're holding crypto, right? Um,
Yeah, it's a crazy trend at the moment. And
it, it, it it is.
we
Go ahead.
sorry we that last topic generated a ton of questions. I'll pop one more that popped up earlier, and
Sure.
then we'll get back into the presentation. So this one comes from Stephen, and Stephen, you posted two questions. One of them just disappeared. So I'll go to your first one. And this one is, do you feel like NPN numbers are a little inflated by automated things like packages that were created to abuse T protocols, that it's highly unlikely anyone would ever find, let alone install? And I think this kind of feeds back to what you said about the tool you used to like automate inflating the number of downloads. So yeah, do you find that download numbers are generally inflated on when it comes to NPN packages?
I mean, yes, no. The answer is yes. I mean, like, it's a really good point bringing up the T protocol one, because it was either last week or the week before that I identified this massive spam, the largest spam campaign ever in NPM, which was an extension of the T protocol. Um, uh, I'm not, I don't know whether I want to call it an attack or just a spam campaign.
Hmm.
Um, I think, yeah, the numbers are inflated a bit, but I mean, the reality is that NPM is the world's largest software ecosystem and registry by a fair bit, right? There's 3.6 million individual packages. There's 134,000 modifications that happen to those packages, either new versions, the vast majority of those are new versions of packages. So I think, yes, the numbers are inflated a bit, but I also don't want us to think that to underestimate the sheer breadth and size of NPM. It's big. And the number of iterations that happen there every day makes it really difficult for any organization to capture every version of those tarballs, every new version, all those 134,000 modifications a day.
Hmm.
People that are tracking that have to capture every single one of those tarballs to be able to do a diff, and that's just very unwieldy. So yes, the answer is the numbers are inflated, but also too, NPM is big, full stop, right? Um, which was there another question, Josh, or we good?
We've got some more, but let's continue with the presentation and then we'll come back.
Sure. Yeah, cool,
Yeah.
sweet. I, I just want to really kind of focus on this. I was talking about it a second ago. Developers are being targeted, and they're being targeted because the bad guys know that they can get good stuff out of the developers, whether that's credentials, access tokens, sessions, what have you. But then they can also use that developer to then gain access to the organizations they work for. So we just have to really kind of focus on how do we protect our developers and how do we get insights and telemetry out of what the developers are doing. And unfortunately, the few security tools that developers are using, things like static analysis, SAST, and SCA, software composition analysis, do not help with malicious package or open source malware. And so, they're not gaining any benefit there in the malicious packages side. And if there's any, when it comes to like EDR at the enterprise, the most two common exclusions that I see, or exclusion rules that I see, are made in the enterprise. The first is for the C-suite, right? The second is for developers. And so the reality is, even if the developers are running CrowdStrike or SentinelOne or some other EDR, they probably or possibly have exclusions that are happening, whether it's individual directories or what have you, and bad guys can target that, right? And developers are using a lot of browser extensions, especially now in a post AI world where there's all this kind of AI stuff. I saw a great article recently about the North Koreans and the latest campaigns and the number of extensions, AI extensions, the North Koreans themselves were using in their offensive campaigns, right? Which is just kind of evidence of the kind of behavior we're seeing out there. So, lastly, bad guys are targeting CI/CD pipelines, and there's a number of reasons for that. The first is very little insight and telemetry going on. Most organizations, aren't capturing the logs that are coming out of those things or running things in real time like UDS or intrusion detection. Um, these CI pipelines are calling all kinds of libraries and containers, and who knows, and they're doing it multiple times a day. Um, and I think a really important thing to talk about when it comes to continuous integration is it's where this kind of crazy intersection between the core intellectual property for an organization, which is their source code, comes in contact with just a crazy amount of credentials and access to your cloud providers, to password managers and all kinds of stuff. So you have this kind of nexus of the source code and all this access happening in the same places. So we shouldn't be surprised that bad guys are targeting CI pipelines. Um, and I gave a talk at DEF CON this year, and one of the kind of takeaways from that is that if you keep your if you keep your package out of OSV or GitHub Security Advisory, you're pretty much good to go. And the reason why is that most of the application security tools that are out there are simply looking at OSV or GHSA, and I'll talk about both those platforms here in a second, to see if a package is malicious or not, right? And because these databases are really underbaked, which is why I built open source malware. It doesn't give a lot of coverage for malicious packages. And I said this earlier, but open source malware, it just doesn't go boom the same way that kind of other types of malware goes boom. It's interpreted, and so you kind of have to come at that understanding that you're not going to be able to use file hashes. And a lot of the kind of tools that you used in the past are not going to help you out here. All right, so I'm going to speed through this because I want to kind of land the last 15 minutes on open source malware. But here's some actual examples of open source malware. So this is an npm package called Hero Stereo, and you can see right there in the post install script, it's calling a reverse shell to that IP address, right, and spawning a bash shell. Now, the reality is that 99.999% of the time, it's not this easy to see, but this is a great example of how easy it is to use a lifecycle script inside of npm to do a really, really bad thing. That post install script runs after the npm package has been installed and all the dependencies have been installed as well. It then runs that command. You now have a reverse shell. And this works both on a developer's laptop and in CI pipelines. And one thing that I've seen bad guys do is if they can get access to a CI pipeline, they will then introduce a second step in the CI that says, hey, create a lot of latency, right? Just do something that's really slow so that my script then has time to go and pull whatever it can from the CI environment. And like I said a minute ago, typically those CI environments have a ton of credentials and access that bad guys can use. Now, the great thing is here, if we're looking at that package, just that simple package, there's a lot of things there that we can pull out of that, which is good, right? We have an IP address, right? We can use that and we can look for that both post incident, right, in our security tools, but also we can add that to any blacklist that we have. The package name itself, that's something for us to go and look for inside of our environments. We can scan SBOMs. We can use our SCA tools to look for the existence of that package in any of our environments. And the great thing is that author published other packages, right? Pasco, Resend, Defuse the Rust, and a couple other packages. We go and look at those packages, we see that there's malicious payloads there too as well. So we can use the author to pivot into these other payloads. Let's take a look at another example here. Now, this one's a little bit different. Web3 parser was a very, very powerful attack. It was originally written and published in 2022, and I identified it in January of this year. So that means that that malicious package was out there ganking crypto assets for a number of years. Now, the reason this typo squatting attack was so powerful is that no one really understood the actual name of the library to call, right? And the bad guys took advantage of that. So this is not an interactive thing, but the reality, this is a question. Which of these is the legit Web3, the most popular Web3 parser for JavaScript? Which one of those three is it? Well, the reality is that The actual legitimate package is called Web3, right? It doesn't say what it does. But the GitHub repo that legitimate package uses is actually called web3.js. But because the periods are not allowed in certain parts of GitHub, it also refers to itself as web3 dash JS. And so the bad guys took advantage of this kind of weird naming construct and the fact that people didn't really know what it was, and they just named their malicious package what it does, which is Web3 parser. And this, unfortunately, that attack was very, very powerful. Now, as you look at the package.json here, you can see there's no post or pre-install script. So this package needs to be imported to work. And lots of people did this. Now, if you take a look at the index.js, it's obviously obfuscated. You can see here some base 64 strings. I've decoded this for you, so you can take a look in the bottom there in the red box what the package and the C2 was. But here's the thing, because this was out there for years, the bad guys published 19 versions of this over those years. And there was multiple payloads and multiple different C2s called out in those different versions. So here's another version of it, totally different C2. This, in this case, this is calling out to a MongoDB database to exfil the data, right? And what was crazy about this package is that this was actually a lookalike of the actual Web3 package. It did the thing it was supposed to, which is to parse Web3 events. It just happened to also then exfil all of those Web3 events to the bad guys' controlled C2 server. So the package was doing the thing it needed to, and people didn't realize that it was doing a bad thing until much later. Now, in this case, this author only published one package, Web3 parser, but it did have multiple C2 domains that it used, and it also called out to an IP address as a secondary C2. So there's things there that our teams can use. Now I'm going to skip this one just because of time. This is another one, another example. Actually, this is a good here. This particular case, this was actually the first time that I saw bad guys using NPM packages as a new initial infection vector for an existing ransomware campaign, right? So this basically, once you got past the npm install portion of this just looked like other, other Russian-based ransomware attack kill chains. But this npm author did publish other packages that had the same or very similar payloads, and because this actually did then basically echo the kind of standard attack chain. There were binaries, there were secondary and tertiary payloads inside of those package, kind of life cycles. And so there were some file hashes. This was the first time, like I said, that I saw NPM being used as this other kind of initial vector. Now, there's two original databases for us to go and look for package data. The first is the GitHub security advisory. You can see it here at github.com/advisories. If you actually search for type malware, you will be able to look for malware that the GitHub has flagged, right? And that's great. Oh, and at the top there, you can see the specific query URL. But here's the problem is that there's basically no data for CTI teams, for teams that are looking to understand, how can I understand, what I can do with this in my organization? All this does is basically give us a binary understanding of whether this package is malicious or not. Doesn't help us understand any of the IOCs or any of the other stuff that we want. There's no explanation of the payload. There's no author or contributor, so we can't understand, did this author publish 1,000 other packages, right? There's no severity or impact assessment. And unfortunately, GHSA only provides malware data about NPM packages. It doesn't cover any other ecosystems. PyPI is not covered, Maven's not covered, NuGet's not covered, unfortunately. And even worse, there's no API to call. So how do we even get this data? If we were even looking for the simplistic binary level data of is it malicious or not, how do we get that into our tools? Now, the other database is OSV, osv.dev. I've been heavily involved in OSV myself. It's a great tool. And you're looking at an actual advisory here. And you can see there's a little bit of an explanation there at the top, but not much more. So while OSV does provide a few things that GHSA does, it's a little bit better than GHSA, but it's not better by much. Sometimes it's going to have payload descriptions, not very often. And very, very, very occasionally, you'll actually see some IOCs. OSV does have an API, but the API was definitely not built for CTI teams, or it doesn't basically have a threat feed example. So you can't use it to pull in a bunch of data about packages. Instead, you have to ask it, hey, is Lodash 1.17.21 malicious? Yes or no? Oh, it is? Okay, cool. Oh, no, it's not. And go on to the next package. Otherwise, it pretty much has the same issues that GHSA does. No impact, no severity, no author or contributors. And that's why I built open source malware. It's available at opensourcemalware.com. It's built specifically to address some of those flaws in OSV and GHSA. It does have description of the threat and payloads. It does include threat actors, and I want to show you this here really quickly in the last few minutes of this webinar. It does have impact. So basically, a lot of bug bounty researchers are flooding npm and PyPI with dependency confusion and typosquatting attacks. But typically, you know, most of the time, those packages don't have any significant impact. They typically will exfil public IP and the host name and maybe sometimes username, right? And that's kind of where the bug bounty world has landed. But if you're looking at uh, a, a malicious package that's flagged by OSV, you don't know whether it was a bug bounty researcher or if it's North Koreans or Russians, right? So there's just no way for you to understand, how do I prioritize my reaction to this. Um, Open source malware also has reference URLs, so you can go and find out more about those individual malicious attacks. And we have tagging, which is something I really, really wish that OSV had. So in other words, attacks can be tagged together, so you can go and search for one thing, like this most recent shy halud. So let me show you how this looks real quick. I'm going to flick over to open source malware. Here's a website. You can search first and foremost on more than just packages. You can search for repositories, CDNs, and domains. And if you look at the statistics of the data that we have in the database, you can see here that in addition to the package ecosystems we also have a lot of data about repositories and other. Did I get signed out? That's coming here in a second. So that's an important thing too that we have in OSM that OSV or GHSA doesn't have, which is that we're tracking malicious repositories too as well. So for example, if you say here, repositories, you're going to see here's a repository that somebody submitted that is part of the North Korean contagious interview campaign. Scroll down. Here's another one, and it's got an evidence link. So we're tracking things that OSV and GHSA are not doing, not just packages. The second thing is that you can search for my internet here at the hotel is not super fast. Oh yeah, wait, there we go. Actually, there you go. All types search. There we go. In addition to the different types of packages, you can search for npm, PyPI, Maven, NuGet, Ruby gems. So we've got data from all these different ecosystems, malicious package data that nobody else has, which I think is really cool. And something we added over the last week is we're now tracking all those VS Code malicious extensions, both from OpenVSX and from the Microsoft Marketplace. So you can search for malicious components and those places as well. One of my favorite tools to use here is we're going to say shy halud. We're going to search, and we're going to see almost 200 different packages that were part of the first shy halud attack. You can see they're individually tagged. If you want to look at all the npm packages, you can click on npm. If you want to see account takeover, those tags are super, super important because that allows you to create kind of abstractions around different categories of attacks and be able to look at them together. CI is a good example. So we've basically all the, maybe we don't have any tags with CI, interesting. But yeah, that tagging is super, super powerful. And it's something that I really wanted in OSV. And unfortunately, it wasn't available. So I added it here in OSM. So I think that's a quick kind of high level description of open source malware. I just really want to quickly go into a couple of recent submissions that have been made. This is a Python package called telco that came in, and this package is actually creating a reverse shell and a backdoor to anyone who installs this telco package. And now the interesting thing is that the threat actor that published this actually published other packages with similar payloads. And in OSM, you can track those different packages or components, not just packages, anything that that particular threat actor is used in a campaign. We're going to tie those together inside of open source malware and show to anybody that's using this data, which I think is super, super powerful. And I really wanted that again in OSV and some of the other tools, and it wasn't there. We're looking at another one here for that Express EXP package that I was talking about. And in this case, because that package was really powerful, had significant impact, there's a lot of references to people writing blog posts and that. And we wanted to make sure that we're capturing all of that too. So that if you want to really kind of go and understand, how this might affect your organization, you're not just, able to come here to OSM and look at the payload details that we have. You can also go out and research it via those links that we've included inside of OSM as well. So I was super excited about that ability to kind of aggregate data, bring it together, let you find those indicators of compromise that you need to be able to do post-incident work. So I think, Josh, at this point, I'm probably going to stop here and see if we've got any questions.
We definitely do, and it's so cool to see that you've gone and built the exact functionality that you wish you had in other databases and tools. So I always love it when people take that kind of initiative and create exactly what they want to see. We do have some
Thank you.
questions.
Sure.
So the first one, and I'm going to work backwards, is where's all this data coming from? Jason wants to know, do people just submit to the site? How does it work? How's it verified?
Great question. All right. So first and foremost, open source malware pulls data from those other traditional tools. So it pulls data from GitHub security advisories. It pulls data from OSV. So any data that's in those kind of core platforms will also be in the OSM database.
Hmm.
Second, we also crawl websites like socket.dev and some of the other websites. And when they have research talking about new attacks and new packages or malicious components, we pull that into the database as well. And yeah, finally, we absolutely have a collaborative component to this. So basically, anybody that signs up, you just use your GitHub account to authenticate. You can then submit packages as multiple people, do every day. Those submissions then are validated and vetted by the administrators of the open source malware site. Um, Often that's me. We validate that that's actually a real threat. And then once we validate that, we release that so people can then find that in their search results on the website. So it's a combination of pulling data from those great foundational places like OSV and then just enriching that data. Second, pulling it from other sources, other websites and other threat intel platforms and other blog posts. And finally, third, people making submissions as well.
Excellent. Thank you. Super useful context. And that's how we get data inside of open source malware. But how can we get it out of open source malware? And can the data be ingested into a CTI platform like OpenCTI?
Yeah, 100%. Yeah, so if you go down to the bottom of any of the open source malware pages, in the footer here, you'll see our API documentation. And you can pull the data from these API endpoints. So you basically have multiple API endpoints here. We do have a sticks endpoint too as well. To be able to use that sticks endpoint, you just need to kind of reach out to me and ask for uh, um, us to allow that, and you can pull that data via sticks as well. And those different endpoints allow you to do different things. You can check individual packages, which you can do at OSV. So I mean that's great if you want to check individual packages. And that's the most common endpoint that people pull from CI pipelines, and that allows them to quickly say, "Hey, is this individual package that's in this package manifest malicious?" I've even written an open source tool called Malice, which you can find in npm, which is really quickly here. Malice. There we go. Yeah, this tool here, you can actually use this in your CI pipelines if you want to. But where was I here? Um, Oh yeah, I was showing you the API documentation. Sorry, I got off filter here. Let's pull, sorry, there we go. I need the top of my thing here. Um, then you can also query latest. So basically, you can just pull that. You can hit that endpoint, and you can pull the latest 100 packages. And we have a lot of people that are just sitting there and polling that API endpoint to grab the latest data that's coming into the database. You can also submit and modify. If you modify an existing record inside of OSM, again, one of the admins of the site will validate those changes, make sure they're legit, and if so, then they'll publish that to the database.
Excellent. Yeah, this is fantastic API documentation. So thank you for elaborating on that. And now we've got another question. I think it's our last one. In an enterprise environment, how can we use OSM or GitHub advisories to check at almost real time that our packages have been or possibly compromised? I ask this because it usually takes 30 minutes to 2 hours before reports come in from other vendors like Wiz, Socket, etc. How can we be on top of these things?
Great question. Um, yeah, so like I said a few minutes ago, we've got a number of organizations that are, basically hitting the OSM API either via my Malice tool that I was showing you there a second ago, or just, you can write your own script, in the CI pipeline, and basically then just um, uh, parses the package manifest file and checks each one of those packages individually. Something I might point out, something that's great about OSM that OSV doesn't do. OSM, you don't have to ask for a version number, right? If you want to ask, if you want to say, hey, is Lodash version 1.17.21 malicious? You can do that. But if you want to just say, hey, is Lodash, any version of Lodash, Lodash, Lodash malicious? I can't talk now. We also support
Monday.
that. So you don't, I know I've been talking a lot here, Josh. So you don't have to necessarily provide the version number, and we'll tell you then which versions of that package, if any, are malicious.
Hmm. Okay, perfect. Right, with that, we will wrap us up on time. Paul, thank you so much. Really appreciate you sharing your insights, and thank you again for this huge contribution to the InfoSec community. Three things I'll quickly point out. If you go over to the webinar chat, you'll see a link where you can go and learn more about 3D threat intelligence. Another link to our next webinar. It's a free sign up, and this webinar will be on MCP servers, as well as a demo of what we've created. And then the third link is to open source malware. So go check it out. And a huge thank you once again, Paul, and thank you all for the great questions. It's been wonderful talking with you.
Cheers. Thanks, everybody. Appreciate
Cheers.
the opportunity.
Thanks all. Bye for now.